Hello all, welcome back. So in the previous videos, I talked about pellicle formation. I talked about how a pellicle is formed, where it is formed, what is the thickness of a pellicle, and also once the pellicle is formed, how the bacteria comes itself and attached. That is, it becomes reversible adhesion or irreversible adhesion depending upon the distance at which the bacteria binds to the pellicle. So I've give you the link of the above videos so you can watch that and come now. So moving on to the final step in the plaque formation, which is nothing but the secondary plaque formation and colonization. So the pellicle, which is a gluey substance, attracts the bacteria because the pellicles acts as a source of nutrients. That is, a pellicle is nothing but the glycoproteins, salivary proteins and the glycoproteins. So what happens, the bacteria binds to the pellicle, it receives the nutrients from the pellicle, it grows, right? So the growing part is called as the secondary plaque formation or colonization. Okay, now so imagine I talked about the primary colonizers. Okay, what are the primary colonizers? Streptococcus mutans, Streptococcus oralis, Streptococcus mitis. Okay, and then I also talked about Actinomyces viscosus, Actinomyces neelundi. So these are all the few primary colonizers of the plaque formation. Okay, so these primary colonizers should attach to itself, and also it should allow the other bacteria, which I'm going to call it as secondary colonizers, to attach to the primary colonizers so that the community of the plaque grows up, right? So similarly, the secondary colonizers of a plaque will be the red complex organisms, P. gingivalis, Treponema denticola, Tundrella forsythia, and also other bacteria, the main bacteria, which is nothing but the Fusobacterium nucleatum, Capnocytophaga species. Okay, so what happens, the primary colonizers which are already formed in the initial bacterial addition, I talked about it, right? So this allows, it makes space for the secondary colonizers to come and attach. Okay, now what happens, say for example, this is the primary colonizers. Okay, it is attached to the pellicle and pellicle is attached to the tooth, right? So what happens, the secondary colonizers, it will have some adhesins which will bind to some receptors on the primary colonizers, and it will start to attach itself to the primary colonizers. Okay, now it's very important, I'm going to call this into two terminologies. Okay, so it is, I can call it as co-aggregation and co-adhesion. Okay, so the secondary colonizers, with the help of adhesins, it binds to the primary colonizers. Now what do you mean by co-adhesion is very simple. Imagine I am a bacteria, I am allowing another bacteria to sit on me, that is called as co-adhesion. So the movement of the free floating bacteria, which we call it as planktonic bacteria, to sit over the primary colonizers. Okay, so it is nothing but movement of planktonic bacteria. Planktonic means free floating. Okay, so the movement of the planktonic free floating secondary colonizers bacteria to attach to the primary colonizers. So this is called as co-adhesion. Now what do you mean by co-aggregation is, see, co-aggregation and co-adhesion will be very confusing. I'll tell you in a very simple way so that you will never get confusion. Co-adhesion is, I'm allowing a bacteria to sit on me. Co-aggregation is, I'm allowing the bacteria to hold my hands. Okay, you find the difference? I'm just allowing the bacteria to sit on me. I'm allowing the bacteria to hold my hands very tight. That is called as co-aggregation. So co-aggregation is the bacterial cell-to-cell recognition of the different species. Say for example, it is not necessary that only gram-positive organisms should hold hand with the gram-positive organisms, another gram-positive. Sometimes gram-negative, that is the secondary colonizers, will hold hands with the primary colonizers. How? As I told you, with the help of specific receptor adhesin complex, This secondary colonizers will hold hand after sitting over the primary colonizers. It will start to hold hands with the secondary with the primary colonizers. So co-aggregation is the secondary colonizers, they attach to the primary colonizers with the help of cell to cell recognition. Okay, and that is going to result in sticking of bacteria firmly, very firmly. So what happens, the bacteria first floats, the secondary colonizers floats, and it attaches to the primary colonizers, co-adhesion. After sitting, it holds the hands of the other bacteria firmly. That is cell to cell recognition of a genetically different species, that is called as co-aggregation. And for this co-aggregation, one very important bacteria that is responsible for bridging of the primary and the secondary colonizers is Fusobacterium nucleatum. Okay, so this is the guy that acts as an intermediate for fusing or binding of the primary to the secondary colonizers. That is, it binds to Streptococcus and P. gingivalis. So the Fusobacterium nucleatum, it binds to Streptococcus and P. gingivalis. So it bridges or it connects the primary with the secondary colonizers. In that way, what is going to happen is very important things called as microbial diversity is going to get increased. Okay, so with the help of co-adhesion and co-aggregation, so the primary and the secondary colonizers, they are going to become friends, right? So what happens, the microbial diversity increases. So microbial diversity increases, and there is going to be a structure or structural organization of plaque. Okay, structural organization of plaque. What do you mean by that? So the plaque is going to become a three-dimensional structure, which is what we are going to call it as biofilm. And the third important thing is resistance to antibiotics. Okay, so with the help of co-adhesion and co-aggregation, what is going to happen, the bacteria, it firmly attaches itself to the genetically different bacteria, and it is going to form a microbial community or diversity, and it is going to result in a well organized structure, a three-dimensional structure, which is what we are going to call it as biofilm. So because of this, there is going to be resistance to antibiotics, because there is going to be a diversity, community, or cluster of bacteria which is not going to allow the penetration of the antibiotics. Okay, so this is what the first step in secondary or colonization or plaque formation and maturation. So there's going to be co-adhesion and co-aggregation, where the secondary colonizers binds to the primary colonizers and increases the resistance of the plaque to the antibiotics. Okay, now what happens, the next step, what will happen is these bacteria, they will release. Okay, so the bacteria releases EPS, extracellular polymeric substances. Okay, so what do you mean by extracellular polymeric substances is, it is basically a glue like substance. Okay, so once the bacteria releases these glue like substance, it will allow the bacteria to stick together. Bacteria stick together and to the tooth. So plaque remains attached to the tooth. So this is one of the main functions of these extracellular polymeric substances, which will be released by the bacteria. So it will release a glue so that the entire group of bacteria will remain together, stick together to itself and also to the pellicle or and the tooth. Okay, so this is another very important step. So now, what are the primary colonizers? Streptococcus and actinomyces species. Secondary colonizers will be the red complex organisms and Fusobacterium nucleatum and Capnocytophaga species. So they stay together with the help of extracellular polymeric substances. Another one important thing is these co-aggregation is responsible for the formation of what is called as corn cob appearance. Okay, so this is responsible for the formation of corn cob appearance. What do you mean by this is basically the corn cob appearance means the center will be Fusobacterium nucleatum, which is surrounded by gram positive organisms, streptococci. Okay, this is what a corn cob appearance. Okay, so corn cob appearance means there's going to be central Fusobacterium nucleatum, which is surrounded by streptococcus species. Okay, this is produced by co-aggregation. So this is what co-addition, co-aggregation and extracellular polymeric substances results. So obviously once the plaque is formed, it matures. What do you mean by maturation? That is a secondary colonization is called maturation. Once the plaque matures, it undergoes mineralization, and that is what we are going to call it as calculus. So calculus is a mineralized form of plaque. So the mineralized form of plaque is calculus. We'll talk about calculus in the next session. So this concludes the plaque formation. So the tooth, after immediately cleaning, there is going to be formation of pellicle. Pellicle acts as a protective mechanism. So the basal layer of the pellicle attaches to the teeth. It prevents a demineralization, and the outer layer is loose, and that is what the bacteria, the primary colonizers, gets attached. And if it is at a distance of 10 to 20 nanometers, that is going to result in irreversible addition, reversible addition. You can remove it, and if it penetrates less than 1 nanometer, then that is going to result in irreversible addition. So once the plaque formation, that is the primary colonizers, becomes irreversibly adhere to the pellicle, that is going to result in a secondary colonization that allows the co-addition and co-aggregation of the secondary colonizers to the primary colonizers, and the Fusobacterium nucleatum acts as a bridge between these two primary and the secondary colonizers. The plaque grows, the diversity of the plaque increases, it becomes resistant to antibiotics, there's corn cob formation, and the plaque matures, and over a period of time it mineralizes to form calculus. So here one very important thing you have to understand is, see, the plaque, because of the presence of late colonizers, P. gingivalis or Treponema denticola, Tendrella fusitia, all these going to result in the destruction of the junctional epithelium, connective tissue fibers, and the bone, because they have lots and lots of virulence factors, which I'll talk in the upcoming videos. So this is how a pocket formation and a bone loss happens after the plaque formation, and this is how the bacteria gets attached itself and gains control over the body's immune system. So I hope this video makes sense. Thank you so much for watching the video. Have a nice day.